JDBC pool properties, maximum number of connections in Spring Boot. This follows the same teaching style as your earlier Spring Boot topic. Introduction. In Spring Boot applications that use databases, connections are not created every time a request comes in. Instead, applications use a connection pool. A connection pool keeps a set of open database connections, reuses them efficiently, improves performance, reduces overhead. One of the most important configuration questions is, what is the maximum number of database connections, and how do we configure it? This topic helps learners understand what JDBC connection pooling is, why it is important, how maximum connections work, how to configure pool properties in Spring Boot, best practices for tuning. This is a critical concept for performance and scalability. What is a JDBC connection pool? A connection pool is a collection of database connections that are reused instead of created every time. In simple terms, pool equals ready-to-use database connections. Example concept. Request means needs DB, means takes connection from pool, means uses it, means returns it. Why connection pooling is important. Without pooling, each request creates a new DB connection. Connection creation is slow, database gets overloaded. With pooling, connections are reused, performance improves, system scales better. Example concept. Pooling means faster plus efficient. Default connection pool in Spring Boot. Spring Boot uses HikariCP default connection pool. It is fast, lightweight, production ready. What does maximum number of connections mean? This defines how many database connections can exist in the pool at the same time. In simple terms, max connections equals maximum concurrent DB usage capacity. Example concept. Pool size equals 10 means only 10 DB operations can run in parallel. Key property. Maximum pool size. In Spring Boot, spring.datasource.hikari.maximum pool size equals 10. How it works. Up to 10 connections are created. Additional requests wait for a free connection. Example concept. 11th request means waits, means until connection is available. Other important JDBC pool properties. 1. Minimum idle connections. Spring Data Source Hikari. Minimum idle equals 5. Example concept. Always keep at least 5 idle connections ready. 2. Connection timeout. Spring datasource.hikari.connection timeout equals 3000. Time mess to wait for connection. Default 30 seconds. Example concept. Request waits means timeout means exception thrown. 3. Idle timeout. Spring.datasource.hikari.idle timeout equals 600,000. Time before idle connection is removed. 4. Max lifetime. Spring.datasource.hikari.max lifetime equals 180,000. Maximum lifetime of a connection. Example concept. Connection reused means eventually replaced. 5. Auto commit. Spring Data Source Hikari auto commit true. Example full configuration. Spring Data Source URL equals JDBC MySQL localhost 3306 MyDB. Spring Data Source username root. Spring Data Source password secret. Spring.datasource.hikari.maximum pool size equals 20. Spring.datasource.hikari.minimum idle equals 5. Spring.datasource.hikari.connection timeout equals 3000. Spring.datasource.hikari.idle timeout equals 600,000. Spring.datasource.hikari.max lifetime equals 180,000. How pool size affects performance. 2 small pool requests wait slower response time. Throughput reduced. 2 large pool database overloaded. Memory usage increases, connection contention. Balanced pool, optimal performance, stable system. Example concept. Right pool size means best performance. How to choose maximum pool size. There is no fixed number, but guidelines include CPU cores database capacity, application workload query complexity, general rule of thumb, connections approximately connection, core count times 2 plus disk factor. Example concept. 8 cores means around 16 to 20 connections. Example scenario. If maximum pool size equals 10. 10 concurrent DB requests allowed. 11th request waits. What happens when pool is exhausted? If all connections are in use. Requests wait after timeout means exception thrown. Example, error. Connection is not available. Request timed out. Monitoring connection pool. You can monitor HikariCP using Spring Boot Actuator Metrics, Micrometer, Logs. Example concept. Observe pool usage means tune accordingly. Using actuator management.endpoints.web.exposure.include. Then, actuator metrics, HikariCP connections active, common mistakes. 1. Setting pool size too high. May overload DB. 2. Ignoring DB limits. Database also has max connections. 3. Not monitoring usage. Leads to poor tuning. 4. Using defaults blindly. Defaults may not fit production. 5. Not configuring timeout. Leads to hanging requests. Best practice. Best practices include: start with moderate pool size, 10 to 20. Monitor usage. Adjust based on load. Align with DB limits. Use connection timeout. Avoid extreme values. Example concept. Measure means adjust means optimize. Advantages of proper configuration: better performance, improved scalability, efficient resource usage, stable system under load. Challenges: finding optimal size, handling high concurrency, balancing DB and app limits, tuning for different environments. Concepts learned in this topic. CAP, what JDBC connection pool is. CAP, what maximum connections mean. CAP, HikariCP works. Key pool properties. CAP, how to configure pool. CAP, best practices. Simple definition. JDBC, pool maximum connections. The maximum number of database connections that can exist simultaneously in the connection pool. Final summary. To configure max connections in Spring Boot. Spring.datasource.hikari maximum pool size equals 20. Key ideas. Connection pool improves performance. Max pool size controls concurrency. Too small means slow. Too large means overload. Tuning is essential. Once you understand this, you can optimize your Spring Boot application's database performance effectively.